वर्क एनर्जी पावर फॉर मैकेनिक्स। मोस्ट ऑफ यू ऑलरेडी जो A2 वाले जो बच्चे होते हैं उसको आसानी से कर लेते हैं फिजिक्स के कॉन्सेप्ट से, बट थोड़ी चीजें लेट्स अंडरस्टैंड देम। Work done is force into displacement, but the displacement must be in the direction of the force. Why? Because you are dealing them as यहाँ पे you are just using the magnitudes. Is that right? वरना you know vectors में technically this is the dot product of force and displacement. And when you do dot product, आप क्या करते हैं? I वाले को when you are doing dot product of two vectors, what do? I को I से मल्टीप्लाई करते हैं, J वाले को J से, राइट? So technically यहाँ पे तो आप सिर्फ इनकी वैल्यूज मल्टीप्लाई करें. So you must make sure that both of them are in the same direction because the dot product of a vector with any perpendicular vector is zero. So अगर नहीं होते सेम डायरेक्शन में तो अगर हम components बनाते हैं, we do different calculations in working, we do not deal them as vectors in mechanics. सही है? They technically are vectors. अच्छा, what about power? Power is work done upon time. Power or energy is where power is work done upon time, work done or energy converted upon time. Is this clear? Another formula for power is force into velocity. ये भी आप work done की जगह you can write force into displacement, right? And displacement upon time is velocity. So power is also force into velocity. This formula will often be used when you're dealing with driving force. So driving force, when you multiply with the velocity, you get the power generated by the engine. Achha, and we are very much familiar with the concept of conservation of energy. ये मेरा अपना बनाया हुआ, do not worry about this. Is just my way to help you analyze and solve problems. What is the concept of conservation of energy? Energy can neither be created nor be destroyed. It can only be transferred from one body to the other or transformed from one form to the other. Is that right? So for conservation of energy, this is one way that I tell students to analyze. The sum of energy providers is equals to sum of energy consumers. So provider and what is an energy consumer? कभी कभार it can be objects और कभी कभार it can be different forms of energy as well. Okay, मैं कुछ scenarios बताती हूँ. Tell me कि इस वक्त energy provider है या consumer है. A car driving up the slope and speeding up. लिख लो scenario को. A car driving up the slope and speeding up. Can you tell me what are the providers in this situation and what is the consumer? A car driving up the slope and speeding up. पहले बताओ ना कौन से provider and कौन से consumer है. If it is going up the slope, what about the delta EP, change in gravitational potential energy? Is that a provider or is that a consumer? Consumer, वो वाली energy बढ़ रही है, तो delta EP is a consumer, right? What about delta EK, change in kinetic energy? Okay, वो खुद energy क्या हो रही है, बढ़ रही है, कम हो रही है? If it is speeding up तो kinetic energy बढ़ रही है. अगर बढ़ रही है वो खुद energy उस form में जा रही है. What about if it is a rough surface? What about work done against resistance? Consumer है. How can work done against resistance be a provider? वो हमेशा consumer ही होता है. Consume कर रहा है ना वो energy. So in so many consumers, वो भी provider ही नहीं है. So what is the provider in this case? Work done by the engine of the car is the provider. So these scenarios में when you use changes in energy, you can use this method to analyze. This will help you. Confusion बचाता है. Different cases याद नहीं करने पड़ते. You just need to understand that if an energy is increasing, कोई energy अगर खुद बढ़ रही है तो that is a consumer. और अगर वो कम हो रही है तो, अगर वो खुद कम हो रही है तो, for example, if I drop an object, what is delta EP? Provider हो गई फिर वो. That is the energy which is being provided and it is converted into different forms. Kinetic में convert हो रही होगी, work done against resistance में हो रही होगी, sound, heat, whatever the case is. Sound heat तो हम लोग deal नहीं करते, but just generally let me. Is this clear? अच्छा, पहले तो in old past papers you won't find much questions which would be specifically telling you to deal with, which would specifically be telling you to deal with a specific method. But अब recent papers में it's a common trend. वो अलग से बताता है कि in this particular question use energy method. So there are many questions which can be done through both kinematics and energy method. So we'll have to use that specific method. Okay, let's have a look at this question. A ball, और इसमें फिर ये वाली चीज भी समझने की कोशिश करेंगे. A ball of mass 1.6 kg is released from rest at a 0.5 meter above the horizontal. When the ball hits the ground, it instantaneously loses 8 joules of kinetic energy and starts to move upwards. Use the energy method to find the greatest height that the ball reaches after hitting the ground. We can take any two moments. हम वो दो मोमेंट ले लेते हैं, हाई वो उसकी इनिशियल एंड फाइनल दोनों के बीच में भी किया जा सकता है. एंड अनदर वे था कि हम ऊपर लेते हैं, फिर कोलिजन वाला पॉइंट लेते हैं, देन फिर सेकंड पॉइंट लेते हैं, वो ज्यादा लेंथ की. ये बेहतर हम कर सकते हैं कि ईपी जो इनिशियल पोटेंशियल एनर्जी थी एंड द फाइनल पोटेंशियल एनर्जी बाउंस बैक करने के बाद, इफ आई सबट्रैक्ट बोथ ऑफ देम, द डिफरेंस इज 8 जूल व्हिच इज लॉस्ट इवेंचुअली. If the energy would not have been lost, the potential energy initially and the potential energy after bouncing back and reaching the maximum height would have been the same. Clear है या नहीं है? So potential energy initially when the ball was dropped and the potential energy after the ball rose to the maximum height again. इनका difference कितना है? 8 joules. Can you find the height then? Potential energy is mgh. Car of mass 1600 kg travels at a constant speed of 20 meters per second up a straight road inclined at an angle of sine inverse of 0.12. देखो, even when you were doing previous questions, I've told you to try to use these as angles when you cannot get exact angles. इससे फायदा होता है हमें, हमारी आंसर ज्यादा एक्यूरेट आता है. Find the change in potential energy of the car in 30 seconds. Rough सी drawing बना लो, that will help you. And if I apply sine theta to the angle, can I say it is equal to height divided by distance up the hill? Hypotenuse is distance up the hill and height is h. Is that right? गर्मी में क्यों? 20 meters per second, the speed is constant and the time is 30 seconds. So I know the distance up the hill. कुछ नहीं किया, basic simple sine theta use किया. Make a drawing sine theta. Sine theta will be equal to height divided by distance up the hill. Hypotenuse is distance up the hill. Is that right? Right, bete? Theta की जगह I can just put in this angle in sine of sine inverse of 0.12. Height I do not know, divided by distance of the hill is 20 into 30. The question says constant speed. ये सारी keywords हैं, इसको जरा गौर से पढ़ा करो. So your height is 72 meters. So you can find the change in gravitational potential energy of delta EP, which is equals to mgh or mg delta h. Okay, now this scenario, conservation of energy will be used. Given that the total work done by the engine of the car in this time is 1960 kilojoules, find the constant force resisting the motion. See, speed is constant. So kinetic energy का कोई change नहीं. What about delta EP? Is it a consumer or a provider? Consumer हो गया. You know, थोड़ा सा time लगता है इस analytical method पाने, but trust me, this will go a very long way with you. So this is a consumer energy. इसमें लग रही है हमारी, right? If it is going up. So delta EP is consumer. What else? What about force against resistance? तो हमेशा कंज्यूम होती है इसमें एनर्जी, इट नेवर प्रोवाइड्स, राइट? वहां तो वेस्ट होती है, लॉस होती है. इज दैट राइट? सो ये दो कंज्यूमर्स हो गए हमारे पास. एंड व्हाट इज द प्रोवाइडर? वर्क डन बाय द कार इंजन. सही है. सम ऑफ कंज्यूमर्स is equals to sum of energy providers. So the provider is work done by the car engine, the consumer is work done against resistance plus delta EP. We need to find the work done against resistance. Sorry, we need to find the force resisting the motion. Work done can be used as force into distance, right? We already know the distance that the car has traveled. So work done against resistance ki jagah I can write force into distance, and I can solve this to get F, which is the force. कह रहे बच्चे? Calculate in kilowatt the power developed by the engine of the car. Power is equals to force into velocity. या तो work done upon time भी कर सकते थे. We already knew the time as well, 30 seconds था. या force into velocity कर लेंगे हम. Okay. इसमें ख्याल ये रखना है कि we need to find the driving force. How do we find the driving force? We can say that force up the slope is equals to force down the slope because the car is moving with constant velocity. Can I say that? Equilibrium में ना, when the velocity is constant or stationary, तो equilibrium में. Force down the slope ही work done against resistance वाली force down the slope है. Weight component of the weight of the car down the slope है. Is that right? And driving forces up the slope. इससे I will get my driving force. उसको मैं वेलोसिटी से मल्टीप्लाई करूंगा तो आई विल गेट माय वर्क डन और पावर ऑफ द कार्स इंजन. एक तो ये तरीका है. दूसरा तरीका हमारे पास क्या है? पहले निकालो इसको. दिस इज वन वे टू फाइंड पावर. पावर के लिए आई नीड द ड्राइविंग फोर्स. सही है. This is one way of finding the driving force, which is using forces or analyzing forces on the object. सही है. Force into displacement is work done. Work done by the car engine. I already knew the work done by the car engine is this. Is that right? Work done by the car engine. Distance जो up the slope traveled था वो 600 था. इससे भी मुझे force मिल सकती है, which is the driving force. क्लियर है बच्चे? दो तरीके हैं ड्राइविंग फोर्स निकालने के. इफ यू वांट टू फाइंड ड्राइविंग फोर्स, One is you analyzing forces on the object and the other is using force into displacement is work done. नहीं आ रही? Another way to find power was you knew the work done by car engine, right? Could have divided it by the time. So yes, you could have just divided it by 30 and you would have got your power. Is this clear? Different ways of finding power. इस क्वेश्चन में तो बहुत सारा डेटा था, तो we could have found power to any particular way.